So we're continuing to understand how exponents work and how they interact with each other. So this first section, I'm going to try to help you see what the rule is, just through experience, by writing this out as long as it can be written. By that I mean the expanded form. So don't worry. Once you learn the rule, you'll see there's much faster ways than what I'm about to show you. But I really do think showing you this at the beginning is valuable because one essential thing in understanding these rules is remembering what does an exponent what does an exponent really mean? So for example, 5 squared means 5 times 5. The squared is just a shorthand way of saying I'm multiplying 5 by itself 2 times. 5 to the 4th really means I'm multiplying 5 by itself 4 times. So now we have a total of 1, 2, 3, 4, 5, 6 fives. So we can write this as 5 to the 6th power. So let's follow this same pattern here. 3 to the 5th means 3 times 3 times 3 times 3. So I've got 5 3's multiplied together. That's just what 3 to the 5th means, is 3 times itself 5 times. 3 cubed means 3 times itself 3 times. So then if you count, we have 1, 2, 3, 4, 5, 6, 7, 8 threes. We can write it as 3 to the 8th power. So 3 to the 5th times 3 to the 3rd is equivalent to 3 to the 8th power. 2 squared, that's 2 times 2. Now we have 2 times itself 7 times. 1, 2, 3, 4, 5, 6, 7. So I'm just underlining so you see the difference between the first term, 2 squared, and the second term, 2 to the 7th. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, this is the same as 2 to the 9th power. And just as this rule will work with numbers as the base, it works with variables as the base also. So y to the 5th means y times itself 5 times. Y squared means y times itself 2 times. So we count 1, 2, 3, 4, 5, 6, 7. So that is the same as y to the 7th power. So now look at, if you need to pause, you can. If you may already see it though, that's great. What do you think the rule is for multiplying powers with the same base? So you can find the pattern between what we have at the beginning and what we have at the end, because it's the same pattern for all 4 of these examples. So it turns out to multiply numbers or variables with the same base, all you have to do is add the exponents. So 2 to the 3 times 2 to the 5th, just say 3 plus 5 is 8, so it's 2 to the 8th. So this is the generic or general way to write it. A to a power, and A could be a variable or a number, doesn't matter, times the same thing, whether it's a variable or a number, to a power. You just add the 2 variables together. So up here you can see 2 plus 4 gave us 6. 5 plus 3 gave us 8. 2 plus 7 gave us 9. 5 plus 2 equals 7. So once you have that in your memory, these go a lot more quickly. So 8 to the 4th times 8 to the 7th, we just say, well, 4 plus 7, that's 8 to the 11th. We have negative n to the 4th times negative n to the 10th, so it becomes negative n to the 14th. Now you do have to keep the negative n in parentheses, just like they did here. We just do 4 plus 10 is 14. Now be careful here. The 2 and the 10 don't have any exponents. The square does not apply, and the 5th does not apply to the 2. The square does not apply to the 10. The 2 and the 10 are separate things. So this, you just say 2 times 10 is 20, and then a to the 5th times a squared is a to the 7th. So make sure you're careful about coefficients where the exponent does not apply to them, and bases where it's the number the exponent does apply to. Okay, here, now yes, there's three pieces or three terms. We still just add them together. 4 plus 2 is 6. 6 plus 7 is 13. So if you're multiplying two things together with the same base, no matter if it's number or variable, all you do is add the exponents together. So I bet lots of you can figure out then what's going to be the pattern when we're dividing powers with the same base. Now you may already have a hint, and that's great, but let's do this in expanded form so we can see visually what's going on. So we have to remember again, what does this mean? 7 to the 5th power means 7 times 7 times 7 times 7 times 7. Divided by 7 squared means 7 times 7. Now when you have a fraction, the same number over the same number equals 1. 7 divided by 7 equals 1. So you cross those two out. 7 divided by 7 equals 1 again. But now the bottom is just 1, because remember, dividing just makes you equal 1. So the bottom is gone, but on top we still have 1, 2, 3 sevens, making it 7 cubed. Okay, on top we have 6 to the 7th, so 6 gets multiplied by itself 7 times. There's a multiplication there. On the bottom, 6 to the 6th, 6 gets multiplied by itself 6 times. And remember, anything divided by itself is 1. Now make sure you don't cross out too many. Here's one pair. 6 divided by 6 is 1. 6 over 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 6 is 1. So all that's left on top is a 6. I mean, you can write 6 to the first if you want to. You don't have to write the 1, but it's not a problem if you do. Now, here again, I'm trying to make sure you see that when we have coefficients, that's not going to work the same way as when we have exponents with bases. So I'm just going to write 15 first. Then b to the 4th means b times b times b times b, because that 4th power does not apply to the 15. They'd have to put parentheses around it like this, but that's not what they did. They just wrote 15b to the 4th. So only the b is being raised to the 4th power. So on the bottom, the 5 times 1b. So 15 divided by 5 is 3. B divided by b is 1. And we'll have to 3 b's on top, which leaves us 3b cubed. So you may have figured out the pattern already, but in case you haven't, take a minute to look at it. Remember, when we were multiplying, we added the exponents together. So when we're dividing, we will subtract the two exponents. So if we have 2 to the 5th divided by 2 squared, we do 5 minus 2 is 3. So here's the generic way to write it. If you have something raised to the b power divided by something raised to the c power, you just subtract b minus c. So 5 minus 2 is 3. 7 minus 6 is 1. 4 minus the understood 1 right there is 3. Okay, 8 to the 8th divided by 8 to the 4th. Just do 8 minus 4. 5 to the 5th over 5 cubed. 5 minus 3 is 2. So once again, pay attention. The 12 and the negative 3 are not related to the bases or the exponents. So do this individually. 12 divided by negative 3 is negative 4. 8 to the 9th divided by a squared, that's 9 minus 2, which is 7. Now g to the 6th divided by g to the 9th. That is the same as g to the negative 3. Now we'll talk about this in a future lesson very soon, but it is possible to have negative exponents. Now that may not make sense at the moment, I understand, but we will explain them in a future lesson that's coming very soon. So it is possible when you subtract to get a negative number as the exponent.